Hello students, today in this video we are going to learn about the second chapter of class 9 science book. The name of the chapter is Matter Around Us Pure. According to the revised syllabus of CBSE, from the exam point of view, we need to study from chapter 2 in chemistry. So let's begin the class. As the name suggests, is matter around us pure? We will have in this chapter we are going to see whether the matter which is around us, which is in our surrounding, is pure or in other some kind of forms. In the first chapter, it said about the matter. Yes, the matter. What are the types of matter? What is a matter actually, and how they exist? What are their basic characteristics? So let me broadly say about that. So about matter is that matter is anything which we can see, touch, and feel. For example, the solid substance like this pen. This is a solid substance and it is a matter. It is pen. As it is solid, we can touch it. We can see it. This pen. And yes, we can also feel this, so we can touch by just feeling it. If you don't touch, see it, just feeling it, by looking at the shape, by feeling the shape, you know that this is pen. So this is a solid substance. This is a solid substance. But liquid, yes, the liquid which we can see and we can also touch, that is also a matter. That is also a type of matter. So for example, the water we can feel it. The solid, in the solid, it is very hard, it is very compact or rigid, we can say, and hence we cannot break it unless and until we apply some huge amount of force. But in case of liquid, we can, if we open the tap and let the water come from the tap, then if you pass the hand through the liquid, the water, then you see that you can cross the water, isn't it? You can pass the water. So your hand is getting crossed from the in between the water. Okay, so that is it. That the particles in the liquid is not as rigid as that of solid particles. So yes, next is another type of matter is air. Air we cannot touch, or neither we can see it, but we can feel it, and hence it also is a matter. Depending upon how the particles in these three states are present, how close they are, their type has been classified into solid, liquid, and gases. In solid, as I said, it is the particles are very close to each other and there is no gap in between them, and hence they are very rigid, very compact. But in case of liquid, it is the particles has some amount of gaps in between them, and hence we can pass our hand through the liquid. So similarly, if we talk about gases, the air, the particles are very, very far away from each other, and hence there is huge gap, and also we can keep in there. Even in this atmosphere here, the air is there already there, but we can keep up a substance. We cannot directly touch it because they are very far away from other. But if we switch on our fan, and then with the speed of the fan, the air blows, and hence we can feel that air which keeps us cool. So that is how the matters are classified into solid, liquid, and gases. In this chapter, we will see whether this matter are pure or not. Okay, whenever we go to market, we ask for certain consumable items. For example, ghee, honey, salt, or rice, or any other such substances. Whenever we go to market and ask the shopkeeper that give us a packet of milk, and we say whether it is pure or not, whether the ghee which we want to buy, we see at the quality, ingredients, and see whether it is pure or not. So this means that the food shouldn't be adulterated. Whenever a common person, a consumer, a common buyer, whenever he or she asks whether the food item is pure or not, by that he means whether the quality of the food item, the consumable item, is good or not, whether the quality is being degraded by adding some unwanted substances which degrades the quality of the food item. So that is what a common person says. This is known as adulteration. Whenever we mix some other substances which degrades the quality of the food, then it is known as adulteration. So a common person, whenever he or she asks whether the food item is pure or not, by that he means or he or she means whether the food is adulterated or not. Adulterated means the quality is not so good. But in case of science, in case of chemist, or in case of a scientist, whenever we say that whether this substance is pure or not, by that he means a more basic, more conceptual kind of thing, more conceptual points come here. Yes, whenever a scientist say when some substance is pure or not, by that he means that a pure substance should be such kind of substance in which the constituent particles of which the matter is made of is same. For example, if we talk about water, H2O. Okay, so water, we know that water is made up of H2O. Yes. Now if you are adding soil, then it is not pure. If water is such kind, we know that water is only made up of H2O. Millions of such H2O molecules come together and form what? And form water, which we can see. Okay, so this is the general conception. Here in water, it has millions of H2O and only H2O. Then it is a pure substance. Why? Because the constituent particle of water should only be H2O and H2O, not any other substance. So this substance which is here, which we have taken the first example as H2O plus soil, it is not a pure substance. See, soil has a different constituent particles and water has a different constituent particles. So since the constituent particles of this H2O plus soil is not same, so it is not a pure substance, but this one is a pure substance. If we talk about another example for say milk, what does milk has? Milk has water plus fats plus proteins. So these are the constituent particles of milk. Though these are different particles, okay, if we talk about water, fats, proteins, though we talk about the pure substance, though these are single way they are different, but every milk, wherever you buy it in any shop or someone's home, or you directly produce in your own home with from the cow you were domesticating, then also you will see that this milk, whether from the goat's milk or cow's milk or buffalo's milk, you will find out that milk has all these three constituent particles and it is same throughout. Every milk has these constituent particles. So this is a pure form. Now this is a pure form, but if you add some other unwanted substance which is not there present naturally, if you have added more water, so if you have added more water, that means what? You are degrading the quality, so you are making the quality bad. So this chemical concentration of this three particles will be what? It will be changed after you have added more water in it. So that has become what? Adulterated. So from the chemistry point of view, when we talk whether something is more pure or not, we talk about its constituent particles. So what is a pure substance? Pure substance is anything which, yes, pure substance is anything which has what? Same type of particles. Okay, whenever a substance, whenever matter has same type of particles, then it is a pure substance. Next we will talk about the mixtures. Okay, next we are going to talk about what? Next we are going to talk about mixtures. So how do you think a mixture will be formed? Whenever different substances will come together, then a mixture will be formed. That means mixture has more than one substance, one kind of substance. That means mixture has two or more kind of pure substances coming together, mixing together, then that is a mixture. For example, let's talk about this rubber band. Okay, suppose this is like the water molecules. Suppose this is H2O and this is H2O. Then they are coming together forming same substance. Let's talk in a more realistic way. This is a rubber band, this is also a rubber band. Both has same color, both are black, their size is also similar. So this is a pure substance till now. If you are adding pen here, again you are adding pencil here. These are what? These are the mixture of pen, pencil and rubber band. Again if you are putting this clutcher, these are all the mixtures. Okay, so this is in just in a simplest way I'm trying to explain over here. So mixture is anything which is formed by two or more kind of pure substances coming together. That it is known as a mixture. For example, as we have talked before, the mixture of H2O and soil. So this is what? This is an example of mixture. Okay, so this H2O plus soil is a mixture. This H2O plus soil is a mixture. One thing it is very interesting to tell about here is that if you are going to think that H2O, already H2O, what is there? If you are going to say that there are two hydrogen and one oxygen is there, then how can it be a pure substance? Because hydrogen and oxygen is itself a two different kind of elements, two different, yes, substance. So how can it be a pure substance? That kind of thing might strike you, because it is water here, H2O, forming when hydrogen and oxygen are combining together and forming water, then it is a pure substance, because whenever they are combining together, they are forming it naturally and mixing it up by chemically it is mixing up and then forming that very particular substance, H2O. This is also a pure substance. One more reason is that you cannot break them into their constituent elements. That means H2O, you cannot break them into their constituent elements. What is their constituent element? It is hydrogen and oxygen. So just by some kind of physical process, you cannot convert or break them down into their constituent particles, into hydrogen and oxygen. Okay, that's why it is also a pure substance. But in case of mixture, what we can do is that we can break them. We can separate the mixture of soil and water into constituent particles, so water and soil, just by the physical processes. Hence that is a mixture. So in case of pure substance, when we talk about pure substances, they cannot be separated out into the basic elements from which they are formed just by physical processes. For that we need chemical reactions. Okay, so hence that is a pure substance. In case of mixture, we can separate, definitely we can separate the mixture of soil and water just by the process of filtration. If you use a filter paper or any piece of cloth you are using, okay, and then you are pouring the mixture of soil and water, letting the mixture to pass through the cloth or any such kind of filter paper, what will happen? The soil will stay in the paper or the cloth, and the water will get passed through the paper or the cloth, and hence the two substances will definitely get separated by the process of filtration. So that is what is about mixture and also a pure substance. That's why H2O, even though they are formed by two basic elements, hydrogen and oxygen, they are forming through chemicals process, and hence they are the purest form. If we talk about more example of mixtures, then we can talk about the lemonade, that lemon drink, which we drink in our summer season. This season we can drink, isn't it? So how is a lemonade made? It is made up of lemon juice, water, salt, sugar. So that is, there are different substances which are forming, and we have formed that mixture. So that is also an example of mixture, and hence yeah, you can consume that. Other such examples are the mixtures of salt in water, sugar in water, or yes. So these are all the some few examples, the basic common examples that we know in our from our day-to-day life. In the examples that we saw, the examples of mixture. So what we talk first about soil plus water, salt plus water, third sugar plus water, fourth lemonade. If you see these examples and this one, you will see that this salt plus water, whenever you make a mixture, a solution of salt plus water, after stirring for a while, you will see that the salt is completely getting dissolved in water. So you can say it as a solution, this one also as solution, because it completely gets dissolved and it completely becomes like the water before we have added salt or sugar in that water. So it completely becomes indistinguishable with the unmixed water. Okay, so it completely becomes transparent, isn't it? So we cannot separate it by just looking at that mixture. You cannot understand whether it is a mixture or a pure form. Only we will come to know when you will taste that water. In this, here it will become sweet, and here it will become salty. In lemonade also it seems solution like, kind of, because it's completely looks like true solution. Okay, so here soil plus water, you will see that there is a layer is formed. Okay, in soil plus water mixture, you will see the soil, you have added the soil in the water and stirred for a while and then left it to stay undisturbed. You will see this kind of figure. Okay, here the soil is there and this is the level of water. So this is water, this one is soil. So you will see that the two layers are formed in this kind of mixture. We all have played here with this mud in water, so we are all familiar. That is the fact. So even though all of them are mixture, there is a difference in how the particles are being distributed. In the example of soil plus water, what happens, you will see, you have already seen this kind of things, that all the particles are not uniformly distributed throughout the mixture. The soil particles settle down here at the bottom and the water is above the level. That means there is non-uniform. The particles, in how they are being distributed, there is non-uniformity. But in these examples, you will see that the particles are completely distributed in a uniform way. So similar kind of pattern is there. Here two different patterns are there. It is all like water only, as the mixture appears just like a unmixed water. So there is some kind of homogeneity in these examples. So those mixtures in which the particles are uniformly distributed throughout the mixture, then it is known as a homogeneous mixture. But if the particles are distributed in just like this way, then in a non-uniform way, then it is known as a heterogeneous mixture. So heterogeneous mixtures are those mixtures in which the particles which are mixing together to form a mixture are distributed non-uniformly throughout the mixture, then we call it as a heterogeneous mixture. And the homogeneous mixtures are those mixtures in which the particles are uniformly distributed throughout the mixture. So that is all about heterogeneous and homogeneous mixture. Now, depending upon this homogeneous homogeneous or heterogeneous. Mixtures are again classified into some different types. Okay, so if you're going to talk about the types of the mixture, these are solution. First type is solution, second is suspension, and the third is colloids. As the name suggests, solution, we already have discussed. Solutions is a type of mixture which is homogeneous. Okay, so solution is what? Solution is a homogeneous mixture. Mixture of two or more substance, just which we talk in the previous examples. The salt plus water, the sugar plus water, these are what? These are the examples of solution. The lemonade also. Okay, if you're going to see in the book, so as it is given in the book, what is solution? A solution is a homogeneous mixture of two or more substances. Okay, in our day-to-day life, we have already talked about the examples that we come in familiar with. We face in our day-to-day life. We drink the solution of lemonade, or we make ORS ourselves with salt, sugar, and water whenever we are dehydrated. Yeah. So these are the common examples from our day-to-day life. Okay, but if we talk about these examples, how are these forms? These are in the liquid form. Basically, a solid, little amount of solid is added to the liquid. Okay, so but a solution can not only in the liquid form, it can also be in the solid or gaseous form. Solid also can be example. Yes, in the solid form also there are some examples. If you say about the solid form, then one best example is that of alloy. So alloy, you know what is alloy? These are mixture of two or more metals. These are again the mixtures which are, so it is, as it is a solution, it will be what? Homogeneous. That means the mixtures from which from the substances which the mixture is formed will be distributed equally, similarly, in a uniform way. Okay, so that is it. So what is an alloy? Alloy is a mixture. Alloy is a mixture of two or more metals, or it could be a mixture of metal and non-metal, metal and non-metal, or it could be a mixture of metal and metal, as I said before already. So okay, so this cannot be separated into their constituent components by just physical metals. For example of such example is what? Brass. Example of alloy is what? Brass. So how this brass is made? Here 30% of zinc is added with 70% of copper. So these are in the what form? Solid form. So brass is an example of alloy. Also in steel, Wood steel. This wood steel is a type which you have maybe, yes, you have studied in the history books. Wood steel. Okay, this in the steel, what happens? There were some kind of group in the earlier history time where the Indians, some of the community in Indians, what they did in Orissa or Jharkhand places, there was a community which used to make wood steel. What is this steel? They do what? They make this steel. So that is also an alloy which is made from carbon and water iron. So this wood steel carbon plus iron together, they form a alloy. So what is carbon? Carbon is a non-metal and iron is a metal. So these are the just a way how I'm trying to explain on the type of solution. So solution can not only be in this liquid form, it can be in both, in all the three state of matter, in the liquid also in the solid state, also in the gaseous state. In the gaseous state, best example is air. So air is also a solution. What is air? Air is a solution. Why? Because air has different constituents. Lots of constituents are there. Not more than two. The millions of constituents are there. Lots of particles, gaseous particles are there, and different forms. Okay, for example, you can say hydrogen, nitrogen, oxygen, argon, neon, carbon, carbon monoxide, carbon dioxide, nitrogen dioxide, sulfur dioxide, water vapor. So many substances are there. Okay, so this, why it is called as homogeneous? Because if we talk about the air, the in this room where I am right now explaining you all this kind of phenomena, all this kind of substances, here also what air is present, and from that air only I am taking up the oxygen and breathing. Okay, so if I'm taking the oxygen from this air and I go outside, I will also get the same oxygen, and also different substances will be uniformly there. What I mean to say is that if I take the air from here and the air from the outside the room, it's not like that only hydrogen or oxygen will be present in this room. This constant will be present here, and outside this constant will be not there. So it's not like that. Wherever you go, wherever we find the atmosphere, in every part of our earth, you will see that the air, everywhere the air has the same kind of constituents, and it is everywhere uniformly distributed. Okay, that is what I mean to say. The nitrogen is in enormous quantity, then there is oxygen, then there is the other substances likewise. So the percentage, which is the percentage of oxygen, nitrogen, these are all fixed. Everywhere it is in the similar way. So that is why they are homogeneous, and hence air is an example which is a homogeneous mixture, and hence is an example of solution. If we have to talk more about the solution, you know that solution has two forms. Okay, solution has how many parts? Parts. Solution, it has actually two parts. So what are these parts? It has two parts. One is solute, and the other is solvent. Okay, so what is this solute? Solute is that amount, that quantity which is present in lesser amount. Okay, it is present in lesser amount, and it is added to other part. Okay, which is the other part? That is the solvent. So solute is present in the lesser amount, and it is added to solvent. So that means definitely solvent has to be what? Solvent has to be in the higher amount. Okay, so solvent is that part in which the solute is added to it. Okay, that's it. If we are going to see in the example of salt and water, suppose this is the salt. Here you have added the salt particles. Now it is here, it's coming here in this way. Okay, so you will see that this solid particles are lesser amount, and the solvent is in higher amount. And the homogeneous mixture, since they are homogeneous mixture, so how they will stay? This way, uniformly they are distributing. Okay, so they will be distributed in a uniform way. So this is what is all about the parts of the solution. So solution has two parts, that is the solute and the solvent. Solute is that part which is added in the lesser amount to the solvent, and solvent is that part which is present in the higher amount or which acts as like a medium. So here it which will be in the higher amount, solvent will be the higher amount, and again the solute is added to this solvent part. So that is all about the parts of the solution. Also in the book there are some examples given. Let's see what the examples which is given in the book. I have already discussed about the solution of sugar in water. So see what is given. A solution of sugar in water is a solid in liquid solution. So what kind of a solution type of solution it is? It is a solid in liquid solution. So in the solution, sugar is the solute and water is the solvent. Again, a solution of iodine in alcohol known as tincture of iodine. So what is tincture of iodine? Here, this one. So tincture of iodine is that which is a mixture of iodine in alcohol. So iodine will act as the solute over here. Iodine is present in solid state, and the alcohol is present in liquid state. So alcohol is act as the solvent. Here I have already discussed the nitrogen that is present in the higher amount, 78%, again oxygen 21%, and the rest are the other particles. So it is a homogeneous mixture of number of gases. Okay, so you can say the nitrogen as the medium. So this properties of solution we have. Let's see what are the properties of solution. So first thing, we know that solution is a homogeneous mixture. Okay, so homogeneous mixture. And also one thing has to be very sure about the particles, about the solid particles of the solution, is that it should be definitely the solute particles of solution which is forming the mixture should be very small. Otherwise they cannot become invisible, and hence only the medium is safe. So the solid particles, the particles of solution, whatever the particles of solution are there, the water, the sugar particles, this actually they are very smaller, which we cannot, because of which we cannot see the solid particles which is being dissolved in water. Okay, so these are so small. What is the size it's given? It is 1 nanometer. What is 1 nanometer? 1 nanometer is a quantity which is equals to 10 to the power minus 9 meter. If we compare nanometer and meter, then you will find that 1 nanometer is equals to 10 to the power minus 9 meter. That is the size of the particles of the solution. So these are so small, and hence we cannot see them through our naked eyes. Okay, so the first is that the particles the solution is a homogeneous mixture. Second point is that the particles of solution are very small, and hence we cannot see them through our naked eyes. Obviously, now since the particles are so smaller, will they be able to scatter the light? How do we see an object? Why do we see this pen? Why do we see this book? Because here this particle is big enough to scatter the light, where the light which is coming from the sunlight which is falling over here and the sunlight is being scattered in all direction. Okay, sunlight is falling over here, and it is scattered in all direction, for which we can see this pen. Now if you take a solution of the sugar solution, if you take that and let the you put a torchlight over there, you will see that the light is it's getting just past, so you cannot see the path of the light, because the particles are so small that their size is so smaller that they are not capable of scattering the light, and hence we cannot see the path of the light. So whenever the light passes through a solution, the path of the light is not visible. That is the third characteristic. And the fourth character is that the solid particles cannot be, though it is a mixture, you cannot separate them. The solid particles of the solution cannot be separated just by what physical process. For example, filtration. Yes, definitely. If you are taking a sugar solution or salt solution and letting it to pass through filter paper, you will see that the whole of the solution will get passed. This is because the pores which are present in the filter paper is bigger. The size of those pores which is present in the filter paper is big enough from which the solute and the whole mixture, the solution, can easily pass through it. So you cannot separate the solid particles, just like we did in the suspension, which is soil plus water, that mixture. Okay, that is the mixture and that is known as suspension. We will read in the next class in here again in the video. In the next video we will study there. Then what we saw, that it passes, but in case of solution you are not being able to separate the solute and the solvent just by the physical process. So these are the properties of the solution. Next, the concentration of solution is there, and other facts will be the suspension, colloidal solution. Again, there are some other parts there which we are going to see in the next class. So that's all for today. We'll see you soon.